Hello viewers, welcome to the session on convolutional neural network. To start with, let us quickly see what is deep learning network. Deep learning is a subset of artificial intelligence and machine learning that involves training neural networks with multiple layers to learn and extract patterns from the data. These neural networks are inspired by the structure of the human brain. They are composed of interconnected nodes called neurons. The key distinguishing feature of deep learning is its depth. That is, these network layers have multiple layers, enabling them to learn complex representation of data through a hierarchical approach. Each layer in the network processes the input data, extracts increasingly abstract features as it moves deeper into the network. Coming to the applications, deep learning models have demonstrated remarkable success across various domains, including computer vision, natural language processing, speech recognition, and other areas such as healthcare, finance, robotics, and etc. The popular deep learning architecture is convolutional neural network. Let us see what is convolutional neural network. It is a class of deep learning models designed for processing grid-like data such as images and videos. It consists of multiple layers, including convolutional layer for feature extraction, pooling layer for downsampling, and fully connected layer for classification. Let us explore further details of convolutional neural network. A typical neural network will have an input layer, hidden layer, and output layer. The CNNs are inspired by the architecture of the brain. Just like a neuron in the brain processes and transmits information throughout the body, artificial neurons or nodes in the CNN takes the input, process them, and sends the results as the output. The input layer accepts the image pixels in the form of arrays. Each pixel in the image is treated as a separate neuron in this layer, forming the input neurons. In CNN, there could be multiple hidden layers which perform feature extraction from the image by doing calculations. This include convolutional, pooling, fully connected, and the output layer. Convolution is the first layer that does the feature extraction from the input image. The output of the convolution layer is thus passed through the pooling layer, which are used to downsample the feature maps, thus reducing the spatial dimensions while retaining the most important information. The output of the pooling layer is then passed through one or more fully connected layers, which are used to make predictions or classify the image. The fully connected layer classifies the object and identifies in the output layer. We should note a couple of things from this. There are two main parts in the CNN architecture. One is the feature extraction and the other one is feature classification. The architecture of CNN looks like this. If you observe this architecture, you can find that the network starts off with the two convolutional and max pooling layers followed by two fully connected layers, which ends with an output layer. The convolution plus the max pooling layer is where the images are recognized, that is, where the features are extracted. And the fully connected layer are where the images are classified into predefined classes. Let us get deeper into the main elements of CNN architecture in my next video. Bye bye. Have a happy learning.